Hello, hello. Hi, everyone. Have you noticed the Duke going down in the cup of coffee? What should have happened with the coffee? Leak over, of course. So this is memory leaks today. The slides will be available. The heap dumps, I prepared for you some heap dumps for your own study with your favorite tool. And also the code is all online. This slide will be, it's on YouTube, and the links you'll get at the end again. So my name is Victor. I have 18 years of coding. For the past 10 years, I've been doing workshops at an unhealthy number of companies. And therefore, I've been through all the domains you can imagine, from banking to e-commerce to satellite business, transportation, ads, games, e-health, my favorite. My favorite, where are you? My favorite. E-health, and many, many others. And I try to take from these workshops that I run every day, basically, the things that I find most interesting and most meaningful, and to compile them in talks like these ones that I would leave as my legacy. So this is exactly an extract from my performance tuning training. And I also have webinars for my community. I have an online community, the biggest in the world, focused on how to write clean, nice, simple code. You should join this. The links are on my website. And I'm also trying to have a life. Good. So, anyone of you came from C++ to Java? From C to Java? How did it feel? Huh? Why didn't you never come back? Why didn't you go back? Huh? So, you know, when I started Java, I loved the fact that I didn't have to malloc and then forget to free. Anyone in the room ever forgot to free memory in C++? Excellent. Wonderful. So, let's warm up a bit the brain. It's still morning for many of us. So, when does garbage collector run? Hit me. When? Random, whenever memory runs out. Huh? Good. And how does it know what memory to free up? That's an interesting question for a Google interview. How would you implement a garbage collector? Let's start simple. The first obvious thing, if you instantiate an object over here, and then garbage collector thinks that it doesn't have enough memory exactly here, will it be able to free this object once you keep a local variable? Of course not. Okay, it's morning. So the easiest way that GC can find the stuff that is not referenced is by using a ref count. So basically, each object in heap has a bit of a number associated, how many references point to it. So every time you associate a new reference, that number gets increased. So for example, it's now becoming 2. If field is set back to null, then the ref count is down to 1. And if you exit the method and the stack frame of this method gets destroyed, then you are left with ref count equal to 0. And then GC, if it wants, it can kill the object you instantiated over here. By the way, this is a very hardcore deep dive. I need to warn you, this is just warming up. So, at some point, however, the ref count is not enough, because, give me an example, in what circumstance, I'm still in the Google interview over here, in what circumstance garbage collector wouldn't be able to find objects by just using ref count? Simple. Circular dependencies, linked list, double linked list, there you go, these objects are never dead if you only use ref count. So garbage collector must jump over all these references to find which of these objects are still referenced. So for example, here, if no one points to this guy can easily be destroyed. Ref count gets to 0. And then because no one loves this guy anymore, it dies along. And everything dies like a domino puzzle, right? Everything just, it's very easy to remove this part on the bottom by just using ref count. However, good luck finding these, right? So for that thing, garbage collector needs to start traversing the heap from what we will see today, and we refer as garbage collector root, GC roots. There are some places, like the variable in the previous slide, that strongly keep reference to objects right now being actively used, right? And then basically what GC has to do is to color the graphs, if you remember, faculty. And this partition of this graph remains uncolored, so die. Goodbye, those objects. Fun. But now, what is the GC root? We discussed already local variables, method parameters. Can you give me another example of something that can keep a strong reference and prevent an object from being evicted? Easy. Static fields, the first thing. Static field or their friends, fields of singletons, right? or sessions, or caches in memory, resource pools. These things never wash away. These things are permanent in the heap. Anything you reference from there is going to stay, despite GC, in memory. And that's enough for now. Let's dive into code. Guys, so there is this code sample that I want to walk you through. There are, let's see how many we are able to do today. But the point is, let me just escape here. This, good. So the point is, I have a project whose code you'll get, Java 17. And then there is a first, and if you start up this, and I want to demo starting it from scratch, I'm going to start the database first. It's an H2 in-memory database. And then I'm going to start the memory app, which is a standalone Java application. So this should just work fine. If I go now to localhost 8080, I'm going to get this wonderful menu of different leaks I've collected with love from all the companies I've been through. And there will be a bounty for you describing me a new type of memory leak afterwards. I will give you money. If you describe me a new type of memory leak, I'm hunting for these things. So the first thing I want to start is causing a lot of memory intentionally, just blowing up the Java to see what it happens. So this, if I click it, boom, it says here out of memory, out of heap space. Let's see what the code looked like. The code of this first exercise looks like this. I'm going to, in a while through, allocate arrays of integers until I'm running out, of course. The fun thing about the memory footprint of this program is that once you call this, I'm using JVisual VM, there are more advanced tools than this, but this is free. Good. Refresh, and you will see the memory going in the roof, and then after a while, falling down back into, but it went up to, what? 17 gigabytes. That's a quarter of my memory right now. That's the default for the maximum heap. But to prevent my machine from breaking down, I need to set a max heap the first thing I do on this project. I don't want this machine to blow in flames. So let's first say I'm going to give XMX 500 megabytes. It's a good starting point. So if I run this project again, if I cause the error again, I'm not going to see the memory going further than that. It's going to max the heap to that amount of RAM. So the heap is 500 megs, and that's it. But you see, this out of memory just went away. Went away for a simple reason, because once the method is exited with out of memory error, this reference, this variable is destroyed, and the whole array that you've accumulated gets washed away. Fun. So I could survive an out of memory. Well, that's very risky, because what if this field would have been here? If the field is there in a singleton, it's going to stay forever. So let's give one more run now to see what changed. I'm going to go to localhost. So this runs. I'm going to click on the first item, right? That's gonna raise the memory of my program to the maximum. Oops. That's exactly what I'm afraid of, not to crash the entire system. Let's see if I'm lucky. Not good. Not good. Not good. Force quit. Let's try again. Told you, it's a free tool. It's a free tool. Visual VM. No worries, it does the job. It does the job, I promise. It does the job for a great deal of stories. So memory app, or not. This one is very fun. Let's go to the browser, actually. If I refresh, if I go to localhost again, even the home page doesn't render anymore. So what the hell happened? The server got unresponsive in a very dark way, doesn't even pick the connections from the network. It's very, very dark what happens over here. I have to quickly restart the app, otherwise we're going to stop the presentation here. So, you see, once you run into an out of memory, if that out of memory doesn't go away, you can hang the process. So that's why you should always shut down the program when you get an out of memory, because you don't know normally where the leak occurred. And fortunately, you would leave a dead body behind, a heap dump on the disk that you can get and study afterwards. I'm going to add these parameters to this run here. So I'm going to give and say here, heap dump on this location. Write the heap dump when you get an out of memory, and then shut down the GVM afterwards. And this is the setup that we're going to keep using for the remaining of today. So now, if I refresh this and I get into an out of memory, it gracefully says, uh-oh, and then if I look, there is a file somewhere generated on disk with my heap dump that I can import. And I want you all to go to your production and make sure you have this set up in your own setup, in your own environment. An XMX or a max percentage for your heap, I'm going to come back to that at the end, exits out of memory, heap dump out of memory, and heap dump path in a folder that survives Kubernetes taking your head. Very, very important. So not only set these up, but test them. Enable them, go to production, and try to use this program or start it with an indecent small amount of memory so that it falls down. Some of my clients complained about sensitive data kept in heap dumps in production. Yeah, PayPal developed a wonderful tool. You can anonymize the sensitive information. It's PayPal, with the focus on pay. Okay? So if they think they're sure, you should look into it. It's pretty nice. And then, besides this, you should also collect and record GC metrics. Now, I have another, if you are really Spartan and if you want to make the regular health checkup, connect to your application while in peak use, in the max of its use, and then take a heap dump to see if there is anything fishy, if there is any large object that shouldn't be there, trying to optimize the maximum amount of load you can take. Now with virtual threads, it's easy to scale the requests to hundreds of thousands, maybe millions. The next bottleneck we're going to hit is memory footprint. Right? So do this, and we set this up correctly. Now let's continue. Next leak. Next leak, it's again a warm-up one. But of course, I have the project killed, so let me restart it again. Good. Let's see the first situation that you can run into. It's a long stack frame. I'm going to click here once. I'm going to click here again and again and again, and then I'm going to connect to the memory app and take a bit of a heap dump. When you take a heap dump from running process, you're going to see here objects that are 100 megs in size. What is this? Let's see.
What does this button do? Please,
Who keeps you?
Do not.
Who keeps you alive, my dear int array of 100 megabytes? And then, if you go for, it's called GC root. Who keeps you alive? It says, I'm kept alive by a thing called, by a variable called the large array on a Java frame. What thread is keeping you alive, my dear friend? Selecting threads, and if I scroll a bit up, I should see something from Tomcat. If my visual VM allows. Here. You can see HTTP neo 8080 exec2, which is an HTTP thread from Tomcat. So, what exactly did I do in that first leak? Well, the example is a bit embarrassing. I got an API call. I executed an API call that gave me back a DTO, which was very large, 100 megabyte. Nice. And that 100 megabyte is kept on a variable on this running method. But then in the work that I started doing with this data, I only needed A and B, two small things from the object. But because the long flow happened while this variable was running, the reference was kept strongly there. How can I fix the problem? Simple. Assign to null. The senior spoke. Big DTO equal null, and you put a comment saying young Padawan. Do not remove this field, this line. Despite Sonar saying it's stupid and IntelliJ is saying, what are you doing? Do not. So this is what you may run into very ancient code that does that. It's very mysterious. A better solution to comments is always better clean code. So guys, the design of this code sucks. I'm calling an API and then stepping into a large complex flow. What can I do better than that? Extract from the DTO coming from outside only the things I need. In other words, Control-Alt-M, extract a method, saying my value object, my own data, extracted from the call I've done outside. Easy. And now if you really want to impress me with hexagonal architecture, you can even put this into another class called adapter. Ooh. And then this adapter does the fetch, all right? And then you just have to call this method over here. Fun. Are you impressed with my architecture skills? Done. Wonderful job. right? So basically, I am extracting the thing, my very object, which is here, carried along. Where are you? It should be public, of course. Yeah, this is not about design, but this particular problem was solved by better design, just extracting the stuff you need. All good? And that you will never have the leak again, of course. I won't demo, it's very easy. Good. This is one leak, first leak. Let's see the next one. Let's see the next one. Good. Now, let's see how well you know Java. Let's see. I'm going to click here. And then I'm going to go to the memory app, and I'm going to say monitor, perform GC, heap dump. There will be a mysterious 20 megabytes object. It's a workshop, right? I'm trying to make it very, very obvious for you. This object, let's see what keeps this alive. I'm going to open it in the new tab, and I'm going to click show me the path to the nearest garbage collector route. And Visual VM shows me that this array above is kept in a field called large array of this object. And then this object is kept referenced by this field called Big Mac in an instance of calculator factory, which is then further referenced by this $0. What the heck is this $0? Let's see. So we have this inner. The story goes like this. I'm going to be very, okay, here. I'm entering this endpoint. I'm calling new calculator factory. This gets created along with its favorite food, a Big Mac. And then this instance, I request to create me a calculator. I get the calculator back, and then with the calculator, I step into some flow that takes a bit of time. And exactly right. What exactly happens? The calculator that I kept reference here is an instance of this thing. So what is wrong again? What's the connection between the running method and the Big Mac? Repeat. Should be static. Should be static, says IntelliJ. Exactly. Why isn't this static? Why is it instance? Because if it's instance, it's going to drag along a reference to the parent class. Damn it. So for example, you can actually eat the Big Mac here. You are in a class, not static, but inner, it's called in Java. In that case, you're going to have a hidden reference to the class around you. Ooh. So how to fix this? Static. Done. Reload. I'm going to reattempt the leak to see if it's gone or not. Easy peasy. Let's try. I'm refreshed here a bunch of times. Oops. Refresh. And then if I GC and I heap dump, there will be no int-array object left in memory. All right? So done. That's the first one. Let's see if you really know Java. Let's see here. You know, when I studied many years ago lambdas, first I didn't understand what the heck is that arrow, and I wanted to see what's behind it. And I used to write code like this. To understand what I should be doing when the filter required me a predicate, I knew to do this. Enter. Anonymous interface implementation. Beautiful. So this is what we have right here in front of us. Now, remember, witness that this object over here is being linked to a stream that I'm returning from my method. First thing first, this is not a very prudent practice most of the time. Returning a stream is dark design. But still, it drags behind the reference to this new predicate parenthesis, anonymous interface implementation, which happens to be in the same calculator factory, which really loves Big Macs. So what's going to happen now? Let's try that. Let's try to demo this leak. I'm going to refresh. I'm going to go and do monitor heap dump again. And I'm going to see two objects of 20 megabytes each, which are linked by the same way, right? But the only difference is that it's $1. Who the hell is $1? It's an anonymous class inside the class in front of you. So the anonymous class in this case, it's an anonymous implementation of the predicate interface. Of course, IntelliJ says, put a lambda, Victor. Put a lambda. It's much better. I know. Now, of course, if you do reference here explicitly the Big Mac in front of you, around you, that will still drag the reference to the object. I hope it's clear. But the moment you do not reference the objects around you in the class you are living in, then compiler knows not to attach a reference to those things. Fun. So this is the solution to the problem, okay? So let me redo the exercise and prove you that this went the leak go away. I'm going to refresh 2 times, I'm going to heap dump, and there should be no inter-array object in the memory. Fun. But now let me undo both solutions. Let me undo both solutions, just for fun. And let me go and upgrade Java to 21, like we should all be doing. Let's see what Java 21 did to these things. So I've put back the promise. I put back the code exactly as I found it originally. And now I'm going to go back to my local host. Let me restart the project first. And I'm going to attempt both leaks again. It turned out by some act of magic, they actually solved these problems in Java 21. So click. Monitor, I have 40 megabytes. And then let's click the first one, click the second one, heap dump, no object of int 20 megabytes. Ooh la la. So you could refactor the code or upgrade Java. As usual, huh? Perfect. But the third solution is only for the guy in the room that said to assign to null. Have you ever seen this before? Only ancient code did that, very old. Before Java 8, something very old. Actually, up to Java 8, you could still do that. Why would anyone, what the heck is this, first of all? Why would you put 2 braces next to each other? Very mysterious. Few of you, I suspect, let me raise the hand. Who has ever seen code like this? Oh my God, it's half of you. I didn't expect that, I swear to you. The thing that happened over here is that people were feeling lazy back in the days and they wanted to construct a map with some keys and values in one single expression. So what they did, they created a freaking subclass of hash map, and this is an interview question, guys. This is a certification question for Java. What the hell is a brace in the middle of a class? It's called an init block, instance init block. It runs as kind of a constructor. This is madness. This is madness. But again, it's a subclass of hash map. And even in Java 21, this is still not solved. Let me show you. Back to the root. I'm going to have here new hash map. Again, and then do the heap dump to show you. Look, this is it. And if I want the GC root, I'm sorry I can't increase the font on this. I'm going to keep zooming the best I can do. I can see here that $2, we already know the guy. It's the anonymous type inside my calculator factory, which is that class hash map extension that I just created. This is madness. So how do we go about this? What do we do to this? Map, and I'm calling the dog, good dog, good dog, good boy, good boy. 1, 2, perfect. Prompt-driven engineering, we might say. Perfect, perfect. Funny enough, if you just say return and I typed yesterday, yes, look, garbage in, garbage out, in front of you. You have to tell the dog, please, my dear dog, map off, thank you. Good boy, good. Right, so let's restart, let's go for the next one. The next one is, so this one with the inner classes, I've seen it in production. Anonymous simple, I have done it in my own code, and this, it's full all over the world. The only thing is that you probably don't want a lot of instance fields in the class you're doing that. I hope. If you do, you're dead. Sublist, this one I did it with my own hands. It's so fun. Let's click. Refresh, 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 refresh. Last 10 size will go up to 10. Okay. If you now go to look at the memory, you won't see anything fishy. It's 40 megabytes, kind of how it should be. Refresh, 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 refresh. So if you refresh all day, you would see a problem. But in order not to do that, I brought a friend. His name is JMeter. He's a good boy. It can fire 2,000 threads. No, in this one. 100 threads, each doing 500 requests on the same API. So fire in the hole. Anything happens? Let's see. Ooh, what is that? What is that? Heat. Is it enough heat, or should I click again? Yes, please. Okay. things are going up, right? And by the way, this is the moment to tell you a story. While, let me do that first. I'm going to increase a bit the heat, 5,000. I'm going to run it. And in the meantime, I'm going to tell you a story. I went to this with such a chart to a grand architect that once wrote C++, and he looked at that and said, look, memory leak. So he looked at the used memory and say, look, the memory of the Java program is growing. Therefore, you have a memory leak. Is this a memory leak? This is not how memory leak looks like. Never, it never looks like this. What just happened over here? GC realized, you told me GC can run whenever it wants. So GC realized you are running out of memory, so it just cleaned up the garbage, correct? So this is not how a memory leak looks like. This is how a memory leak looks like. I see some nodding heads. This is, okay, I want to talk to you afterwards. If you have ever seen a chart like this, please approach me at the end to tell me your story. I'll tell you about the bounty. Huh? So this is growing, growing, growing. This is kind of similar with what we see here. So you see, it's always good. The GC always tries to push down, but eventually it gets up. Now, still, you might feel it's 400 megabytes used if you perform on GC. However, that's going to drop a bit. 452, not much. So it's up over there. This is how a memory leak usually looks like. Now, if I heap dump, and if I look in the memory, I won't see any strange, suspicious, large instances anymore. This is no longer, this is reality right now. So the code looks like this. I should ask you first, although while asking, what is wrong in this picture? What is wrong in this picture? This is a bug I did. I'm going to, in the meantime, capture a memory snapshot with IntelliJ, because JVisual VM cannot solve the problem I'm going to have to. What is the issue here? Do you see? I'm trying to preserve the last 10 elements in the list by doing sublist of the previous list, starting from 1 up to the end. Oh, how did you know that? Did you do it yourself, or are you teaching Java? Nice. Sublist. So he actually read the freaking manual. He actually read a view. What does a view mean? It keeps a reference of the original list. So how can we see that? Now, there is no suspicious object that JVisual VM can see. And I have to click this button. The problem is that there are tens of thousands of elements right now. And if I clip this retained size, it's going to take a monstrosity of time. So first of all, I have to define what retained heap looks like. Tell me, what is the size of this class? How much memory does an instance of this class occupy? Let me walk you slowly. This, how much memory is this? 4 bytes. This, 8 bytes. This. If anyone said, ugh, that's a problem already. If you said, ugh, it means you're counting the characters, you're multiplying by 2, and shit, that's a lot of work to do. And if you're doing that, you are already wrong. Because any string appears as a literal in your source code gets put in the string common pool. It's a special place in heap where strings go to die, and this is just a reference pointing to that object in the string common pool. So if it's just a reference, how many bytes? 8 64-bit machines. And how many bytes if B held 100 bytes? Also 8. Very well played. This is basically what you computed is called the shallow size of this instance. The shallow size means how many bytes does an instance of this class really, and it's a very hot thread on Stack Overflow. How the hell do we compute that? It's not that easy, right? But this is just the shallow size, right? So it's about, what's that? 28 bytes. Now, in heap analysis, we are always interested not in the shallow size, but in the retained size. If B drags along a bunch of objects, I'm interested to know if A dies, how much memory will get freed up. So this is what we call retained size. How much memory would free up if A is removed? So in this cluster of objects, there is no reference pointing to anything inside. This starts to get dark. If there is another object, another someone else in memory who keeps a reference to this guy, you cannot count this size onto the retained size of A, because this knows as well of it. Very dark in practice what happens over here. But to compute the retained size, if this is 5 and this is 4 and this is 3, you have to literally sum up all these numbers together, right? And then cluster them up to the place, to the entry, let's say. This is retained size. If I would try to compute retained size by clicking this button, it will not finish in an hour. So I would use a more professional tool, IntelliJ, who showed me that there is an array list which retains 369 megabytes of RAM. Okay, what exactly does it contain? Let me show it a bit, opening tab. This array list, okay, contains 36,000 positions. It has 300,000 positions. Now, inside of it, there is a sublist. How can I show you this? It's a sublist that keeps a reference of a sublist that keeps a reference of a sublist. Let's try to snapshot again. This element data is this sublist. It's a sublist that keeps as a parent a sublist that keeps as a parent a sublist that keeps as a parent a sublist, all pointing to the array list over here, keeping all the memory, all the RAM together. So it never freed the element you removed. How to fix it? Instead of sublisting, which keeps a reference to the previous list, or remove 0, but then you have to turn this into a linked list, probably, for be more efficient. You're just going to remove from the beginning. Right? You are trying to implement a sliding window over here. Yeah? Only the last 10, so when one is up, one is in, the other one from the beginning is out. And that's going to solve the problem. Okay? Okay, that was fun. Next one is dark, also. Next one is dark. Next one has to do with something deep. I'm going to show you straight the code. I am opening an XML and parsing an XML with XML DOM. Anyone? Anyone heard? Anyone remember the times of, yes? XML DOM. I am parsing an XML. And I am extracting from 1,000 XMLs. I am extracting from 1,000 XMLs all the tags that are named Java version. I am actually scanning my own POM and extracting the Java version tag out of it. I have 1,000 XMLs. Each has a single Java version. I'm revisiting the same 1,000 times. If I now try to play this game, okay, I'm going to connect to this, do the heap dump, and then I'm going to go to instances, and I'm going to look for the element that I think I'm keeping in memory. In this list over here, I have elements of type deferred element input. How many elements do you think I have now in memory? More. Clearly not 1,000. More. Why? Let's see. How many, first of all? We have here 60,000. I thought there were 1,000. What happens? Why, in my list, am I keeping so much memory? So let's see again. I will click the retain size. So the list that I think I'm keeping 1,000 elements in, each element keeps a reference. Let me look at that, the field. In the first element of this, you have a deferred element, which keeps a pointer to the root of the DOM tree. So it turns out that when you parse with DOM, every element in an XML keeps a reference to the parent root document that it belongs to. And because it points to the document, the whole tree of XML is kept in memory. Fun. This smells of reality, huh? It comes from one of my clients. So they thought they could just gather elements with stacks from all over the place, but it turned out they were keeping, and also applies for JSON parsing. If you do JSON path, the same would apply. They will have a pointer to the parent root element, to the document, keeping everything in memory. Okay? I'm not going to fix this. I'm just going to point you how you can find these things, right? Good. Let's go for the next one. Magic. And this is where I want to slow down a bit because this is dark. This is going to be dark. Magic can hurt. Used heap, 58 megabytes. Let me refresh again. Okay. Ooh. If I keep refreshing, will it blow? Remember, I put 500 max. Let's try. Aww. It doesn't blow. So I'm safe. Look, let's look at the memory here. I'm going to clean up a bit. What do we have here? We have 262 megabytes. It used to be 40, if you remember. 262 megabytes of RAM kept actively referenced. Let's look at where that is. You're going to meet again our beloved objects of 20 megabytes. I'm going to put it in the new tab, GC root. And now I'm going to ask you guys if you know already what happens. That's fast? I can't believe it. That's fast. Someone was like, and I barely displayed it. Come on. What do you think happens behind the scene? I did not show the code. For such leaks, you will never see the code before you find the leaks. These are magic leaks. You don't see them coming. So we have the object, big object, 20 megabytes, referenced in a field called big by a nested class called request context belonging to this class. And then that instance is kept referenced in the value of a ThreadLocal map entry. What is that? ThreadLocal map entry. And it belongs to exec 9. How many of you are there? One second. No problem. You can spin off more instances. Who cares? It's just 200 megs doing nothing. Guys, this is a didactic example. The leak won't be 20 megabytes each. But you see it? It remains in memory. Okay, but why 10? Because by default, Tomcat has a pool of 10 threads kept active to serve your HTTP requests. But what if there were more threads? Well, in order to get more threads in the game, I have to give it some heat, right? So, you know, my friend? It's back. So 200 threads, infinitely for 3 seconds, keep firing at my API. By the way, I do use here JMeter, but in the code, there is also example using gatelink. Some tests that you can actually automate, and they are a bit more, let's say, more nerdy. Look, it looks nice, huh? Exec, I'll inject close. I do advise you read into this, or K6 for that matter. These are the 3 tools we have today to load test. JMeter, gatelink, the one that you have in front of you, and K6. Good. So we have a lot of memory because those many threads just took your system down. So you see, it's not correct to say over here that we multiply 10 threads. We multiply maximum 200 threads, the maximum thread pool for Tomcat by default, with the leak that you have per thread. So that's a bit more emotional. Huh? You don't have to leak 20 megabytes to have a waste of memory. So let's finally look at the code. Let's finally look at the code here. All right. It's called ThreadLocal. So the code looks like this. Very simplified. It's a controller method that is entered. I have a username normally fetched from a request header, jot token, session, I don't know. And then that username has to get into the modified byte in the repository. Sounds familiar? That beloved column we have for audit trail, okay? And now this current username is brought in through this magical ThreadLocal that I have in place. But let's see life without it. How would life without that ThreadLocal be? Well, I will have to get the current username from somewhere. And the only place without magic that you could bring it from is as a parameter. So the repository will ask for the service layer to get a parameter, which will in turn ask from the controller to pass the parameter with the current username. So now you see, I've solved the problem I had without ThreadLocals, but nowadays all my methods everywhere will have current username. Right? And that's going to be a ubiquitous parameter, user stakeholder. So that's going to be a ubiquitous parameter. So what did we do? We vanished it, hocus pocus. Hocus pocus is somewhere out there in a static variable. First, before I continue, I want to ask you, how many of you are already familiar with the concept of ThreadLocal? ThreadLocal, not all of you. More than half, but not all of you. This is fundamental for backend systems to make your code easy to maintain and clean off the dirt of the noise. So this ThreadLocal keeps an object of this type, in which I've attached with love a didactic object to find the leak faster. And that object propagates the username through the layers as long as you do not change the thread. If you change the ThreadLocal data is gone, is lost. We will do later lifting of ThreadLocal data. But for now, we have used the tools of the gods to propagate the username invisibly across our code. Okay, in this particular situation, how would I fix the problem? Clean it. So ThreadLocal remove. Am I done? In a final, thank you. This exactly happened. This exactly happened. They set the ThreadLocal, they did the remove, but there were exceptions. And those exceptions caused this not to run, and they've just left some stuff on the current thread. So this should be in a finally block, of course. Done. Beautiful. If I refresh, restart the application, and redo the exercise, it will not leak anymore the data. So let's give it a shot. I'm going to reconnect to the process. Refresh, 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 refresh. Oh, nothing changes, you see? Beautiful. That ThreadLocal is gone, is gone. Good. So this ThreadLocal is basically magic that we are using to pass along some metadata across a flow to downstream methods that we're calling in our application. All right? Just a second. I thought. 1 second. Good. Good. So you see, in this slide about the garbage collector route, there is a missing piece here. Besides the stack frame and static fields and their friends, there is a missing piece which is very often mysterious, ThreadLocal data. ThreadLocal data, which is invisible things belonging to the thread executing the code at that moment in time, right? And now there are 3 main things that you can find on ThreadLocals. Security context, I'm talking Spring now, security context holder, or reactive security context holder, but that's in the reactor context. Security context lives on the thread in Spring, and basically any other, I think. GDBC connection also and transaction propagates with your thread invisibly between the methods. And telemetry things like trace ID, logback MDC, request scope, hotel baggage. Anyone started attaching more things to open telemetry baggage going through your application? One hand. Okay. If you find something interesting in your flow that you want to put in the log for all that follow you, research into what we call open telemetry baggage. Fun stuff. But trace ID is the most important, to correlate the logs of applications with each other when you put them all together. Okay? So these ThreadLocals are interesting for this. For completeness, I'm going to add one more friend here. Not a friend, but I have to do a... Ew. You know, you can invoke C++ code from Java, and you can actually pass references to things in Java to C crash. It's very, I'm not going to go there. I'm not going to go there today. I tried to put C++ on the projector. It failed before. So I don't want to try C++ on Deadlocks. I'm sorry. Right, good. So I'm not going to demo that. Back here, ThreadLocal remove. But even more than that, guys, there is even more than, I don't want you to start inventing your own ThreadLocals. I don't want you to start managing, playing with these tools. These tools are tools of the gods. Don't do that. If you want to attach something to the current request, research into the concept of a request scope in Spring. Request scope. Define a bean that let the framework manage this for you. Right? I'm not going to continue more on that because it's a bit dark. Right? Managed by Spring. Right? Use request context managed by a framework, or attach more things to your security context. Right? Don't create your own ThreadLocal things. Right? If possible, avoid. Or if you do want to play with it, be very careful to remove them at the end. Fun thing, like 15 years ago, maybe more, there was, again, in the dark ages of thread pools and ThreadLocals, people weren't very confused, and someone forgot to clear the user principal from the thread, of a worker thread in a thread pool, and every now and then, by chance, your action might have admin rights. So you, by clicking the same button, deny, okay. That was really freaking scary. They leaked information about who the user was on the worker thread to the next. At this point, someone should stand and say, Victor, are you showing us thread pools? Don't you know thread pools are dead? Long live virtual threads. What did I say? Thread pools are dead. Long live virtual threads. Free threads, everyone! Free threads! Fun. So let's play that game next. Let's play that game. I could insist on this exercise as well. By the way, this will fail identically with virtual thread. No, not identically. These ThreadLocals are gonna be removed when the virtual thread finishes processing, because virtual threads are not pulled back in some thread pool. Spinning a virtual thread, attaching a ThreadLocal and ship it out, it will guarantee that the ThreadLocal will not remain more than needed. Make sense what I'm saying? Do you follow? Right? But what other dark leak can happen with ThreadLocals? And this happened to Jackson framework a year and a half ago. You have a library and you're calling a method. And that method is from a library that you cannot change. Simply, you cannot touch this.
Can't touch this.
But in that library, built many years ago, when thread pools in Java were the way to go, right? For many decades, that was the way to go. What this framework is doing internally, they need for their work to get some context of their own. But you know what they do? They cache it on the thread. By looking further, you're going to find the Jira ticket explained here in 2010. The client threads should return later as they are probably pooled. What? The threads that the client is going to use to call this method is probably going to come back to us again, because in Java we use thread pools for efficiency and birth control of the threads. So that's what we have to. So here, you see what they did? They were looking in the ThreadLocal, and the ThreadLocal is managed by the framework internally. Jackson had this. They kept some object model in a ThreadLocal variable, hoping you're going to get back with the same thread. So what they do? They do the expensive init. They set the context on the ThreadLocal. They return it. Second time you call, you come back with the same thread. The thread is going to find the information on the ThreadLocal and immediately return back to you, right? So let's play this exercise first to understand without virtual threads by hitting it gently with one call at a time. Let's see. To see it in action, basically. So we call it ThreadLocal cache. Click. If I click that, right now I am not in a virtual thread. If I click that, right, you're gonna see in the logs, right, that this would be initting for different threads. But you shouldn't see it happening again if the same thread comes back. There are 10 active threads by default in Tomcat. I have to refresh a bunch of times. But after a certain point onwards, all the 10 threads will have their own stuff. So you won't see anything, you see? I'm refreshing here, and there is nothing in the log. And if you paid very much attention, you could see it's a bit faster, a bit. So they cached that initialization on the thread by keeping the memory into the guest thread, let's say. So how can this go wrong with virtual threads? Let's enable them. So resources application property, I'm going to go here, virtual thread enable true. Restart. Now I am with virtual threads, this assumption they took doesn't hold anymore. They will attach stuff to your thread, you're going to move through, and they will just sit there on your thread, not doing anything, hoping they're going to do something again. It's basically a waste of memory. I am now running on Tomcat handler 0, which is a virtual thread, it says here, right? So up until here, right now, no issue yet. If I do it with bare hands, it's hard to show the problem, but I have a friend. What if I fire 2,000? It's virtual threads. So, 2,000 parallel calls. You could never serve 2,000 in parallel with normal Tomcat. With virtual threads, why not? You want more? One more zero? Two more zeros? Three more zeros? No. For 7 seconds, I'm hitting it in a loop with 2,000 threads. Let's see what happens. Let me connect to the process. Boom, boom. The glitch here, the actual philosophy behind is that the library is keeping on the thread. What happened? Oh God, 500 and a bit. Oh God, what just happened? Oh no. Now, let me show you the pseudocode of this. You see, after I call the library method, I start on my own application logic. I will never use the library again, for example, on a certain flow. I've parsed the freaking JSON, I don't know. And from there onwards, I will carry along in the virtual thread the information they've set on ThreadLocal. Make sense? Again, several weeks ago, someone was a bit confused, asking me, Victor, do virtual threads have ThreadLocals? Yes. So basically, what you see here is that the ThreadLocal, heavy ThreadLocal set on a virtual thread could be there for no reason in the future, right? Again, this is a double-edged sword. If I will do the library method again after a while, it's going to have to re-init. You see? They'll have to re-init. So what Jackson did a while ago, they re-engineered this part inside of them so that they use a cache which is shared across virtual threads, not per virtual thread. Long story, right? So under high requests per second, virtual threads are now burdened with this extra data onto them, right? How to fix it, by the way? Don't use virtual threads. Go back. I mean, don't go. Actually, I agree with you. Don't use virtual threads without a need for them. Let's phrase it like that. Or if you do play them, and you're going to see them failing again to us later, the tooling is not that great yet around them. But virtual threads are a very deep change in the way JVM works that you don't want to take it very easy. You know, to be careful. Do I have reasons? Am I bottlenecked by the amount of threads that I can take at one point in time? Am I spinning off threads? In a nutshell, it goes like this. Are your nodes limited by their parallelism, by the number of threads they can run? Or are you limited by CPU in the ceiling or memory in the ceiling? If CPU in the ceiling or heap in the ceiling, virtual threads will not help. Virtual threads help if the number of threads allocated in the outside of heap are too large, right? And if you want to serve more traffic with less instances, for example, in a gateway or in an application serving input from sensors under heavy requests, just for fun, no. So first solution is correct. Do not use virtual. What else can I do? There is something else I can do. Clean, but how can I clean them? Because this is in a library I cannot change.
Can't touch this.
And it's freaking private.
Can't touch this.
Come on.
Can't touch this.
When's the last time private ever stopped us? So, I told you you won't like it. I wonder what the heck is this? Don't judge, don't judge. So, exactly here, I'm going to clear thread like this. Agree? Done. Beautiful. That's what my client did. Solve the problem. Before doing that, though, I would invite you to upgrade your libraries. You should be doing it anyway for vulnerabilities nowadays. So, who knows how you handle vulnerabilities today. So, let's run again the whole flow. I should be showing you this. The thing is that I'm releasing out the memory immediately after the library attached it. So I don't keep it for too long. This is freaking hard to find, really. Very hard to find. If you were to debug this yourself, right? That's why it's good to have them in some lab environment. You do see the library initting for every single virtual thread, of course. Yeah? Are we good here? Are we clear about what you see? All good? All good. Fun. Let's see what's next. Next one, just before I give you the break, there will be a single break in about 20 minutes. I need to discuss more about async work. This is another type of leaks that I want you to think over in the break. So let me refresh the application, restart to start clean. And I think I want to start this time with the code. Yep. So once upon a time, you received a call for which you wanted to fetch some data from remote. Please imagine here, I'm not sure why I feel like drawing a bucket in this place. I don't know. Let's draw a bucket. Do I draw a bucket? Thank you. You fetch a file from somewhere. Come on, bucket. I have a problem with my emojis. Don't work. Thank you. Maybe a bucket, maybe FTP, you name it. But you're going to reach over the network to fetch some large data. It's a file in this game, okay? Now, because you don't want to keep the caller waiting for too long, then what we do, we start the work to process this data asynchronously. Ooh. I have a better... Like Venkat famously said, completable futures have no future. But this is fun. What is wrong in here? Come on, when you review this, you should immediately hit it. Shout. A return code. Failures. So he's mentioning failures. If that thing I'm running failed with an exception, would I find that exception? Short story, no. Yeah, we'll demo this. An exception fired from this code? Actually, well, let's demo now. What if this process over here had a bug? Let's try. Guys, I should be seeing in my log a bug, correct? Beautiful. Let's try. Click. Refresh a couple of times, just to be sure. Go back here, and I see task started, and then nothing. Absolutely nothing. Task 7 started, no bugs. You had that, huh? If you completable future run a thing, what you really get, if there is an error, this is freaking. I'm not convinced all of you understood what you're seeing here. You're seeing nothing. There is a freaking bug in your code, the runtime exception bug, and you never get to see it in the log. Why the heck? Because the moment you're using completable futures, this thing over here gives you back a completable future of void. Don't you like respecting void and putting a big V? Void. That completable feature of void allows you to chain, just like TypeScript style, dot exceptionally. Do you want TypeScript today? Catch. If you know what I mean. Exceptionally. And whatever you want, that's what you have to do to log the thing you're trying to. Damn it. And we will all forget to do this. Good. That's one problem. There are two other problems on this practice. What else can go wrong? Guys, I will have another talk tomorrow about event-driven pitfalls, and there will be a moment in which I mention something like this. Kafka listener. Play the game like this now. You receive a message, okay? You receive a message, and you process it asynchronously. Errors are gone. What else is wrong? Again? Rate limiter in the sense of too much load on me. Guys, both Kafka listeners and get mapping, this flow, this endpoint finishes immediately, correct? It just spins off that thing, that new thread, and then it returns. There is nothing stopping the flow. So technically, this request, if you look in network, you're going to see this call coming back immediately, 42 milliseconds. So they can fire against me like maniacs with this because nothing stops them. There is no sort of backpressure, no sort of throttling in the game. I'm just going to accept anything you give. Okay, so what's wrong with that? What's going to happen if you accept anything Kafka or API gives you? Remember that we are here talking, we are gathered here today. It's going to blow memory. It's going to blow memory because, here comes the fun part. By default, in what thread pool do these run? Let me show you here. Ever heard of common pool? Fork, join pool, common pool? Ever done parallel streams? You work in that. If it's a compatible feature like the one I show you right now, you are working on that thread pool, and that thread pool has a queue of size infinite. So that queue has, that thread pool, in the default one in JVM, has no upper limit for the queue size. Perfect. Let's try. 1, 2, 3, 4, 5. Am I doing the right thing? And so what? Why shouldn't I use virtual threads here? I forgot this is like super cloud programming on steroids we're doing over here. 500 seniors looking at me. I cannot make a single mistake. Thank you. I threw exceptions and which stopped the flow. Oh, joy. Can you hear that sound? Dead. Beautiful. Because the queue is unbounded in any way. And trust me, you don't need to retrieve here 10 megabytes. It's enough to retrieve 1 kilobyte under heavy fire. The same happens. The queue inflates and kaboom. Now, this one, I want to do the post-mortem on this hashprof. So, not to confuse you with many tools, I'm going to use the same tool here, although IntelliJ would have been better on this. Actually, it's going to be very... You know what I'm going to do? I'm going to restart the application and take a snapshot while it's still alive. It's a free tool. Oops. Where are you? Refresh. Just about to die. Those of you okay. Heapdump. Now let's do retain size analysis, compacting the sizes of everything together. And we see here a fork join pool. What is this? Fork join pool instance number 1, keeping 146 megabytes. Let's study this. What exactly is so large in you? What exactly, let's see, fields. What exactly is the, I wonder what is this?
Ooh, what does this button do?
Now, things are a bit dark in this game because there are a bunch of queues, not a single queue. But it turns out that you have here queues, a bunch of queues, you see. And each of these queues keeps a number of elements, 10 megabytes each, for a total of 146 megabytes waiting in the queue. What should I do to avoid this? Or to prevent, to detect? What can I do? First of all, from a DevOps point of view, I'm submitting to a thread pool that has an unbounded queue. By reflex, what you need to do immediately is what? how can I limit the pool size of the JVM internal fork join pool? On what rate? It's tough. The rate is not really your problem. The problem is the queue size. It's delicate discussion, rate limiting. It could be the best for some cases, but any other idea? I cannot control the pool, the queue size of that. It's not fair. What else? Use a different pool, limit the number of rate limiting, basically. Use a different pool. That's going to be a good idea. But if you want to play with still with a fork join pool, you can do, where are you? This. What do you think this does? So it exposes 3 metrics, you see? It exposes the metrics of how many were submitted in total by now, what are the threads working right now, and how big is the queue. Woo. On the fork join pool in JVM. So let me refresh again, and then go to the metrics exposed by this and search for VGP. Queue size, 9 elements are sitting in the queue. And what should happen if more than 100 are there? Maybe. Alert, an alarm in production. So that would be what you do for an existing system. You instrument the code in one place and you have these metrics exposed and kept monitored, okay? If you are already in this game. So we discussed 2 problems of this approach. One is that exceptions are lost, and then the queue is unbounded. Is there any other problem or reason why you should never do this in a Spring Boot application? Or Quarkus or Micronaut or Java EE? Injection of what? Injection. What do you want to inject? It's a tough question. Injecting Spring stuff. What do you mean? You want to inject Spring? Nah. Probably you know. Probably you're on the right track. But any clearer answer? What exactly is the third problem? So first are exceptions. Second is the queue, which has infinite size. And third problem? Guys, I want to ask you one thing. Let me reboot the application and refresh. Do you remember ThreadLocals? Let me show you this. It's very fun. Have you ever seen in a logback pattern something like percentage %X? And now you could be using some JSON format and you might not see this, but what does percentage %X do? MDC accesses the ThreadLocal logback MDC to get the information about the trace ID that you are executing on. So you see that my task here printed this log, got byte. Got byte has this mysterious 1 in here. But that mysterious 1 is never reaches the actual common pool worker. Do you see this? There should be, if someone just steps in right now, they will think we are lunatics. I'm talking about the 1. This 1 should be here. The context propagation, what I call lifting of metadata from the parent into the child. So let me refresh it several more times for you to better see the point. You see, this is the task ID. The trace ID, if you want, that had to be propagated on the worker thread. It's not propagated. So that's the third thing why you should never use common pool in a flow serving an HTTP request, for example, because you will lose the trace ID. This is one of the reasons some traces are stopping in a system, because they played with threads and they forgot to move the thread local information to the worker thread. Guys, so what do you think this does? This is probably one of the most difficult code I show in my Spring training, but still. Executor, by the way, this is a thread pool task executor, a Spring class, with 4, 4, and 5. Beautiful. And then this. What do you think this does? Well, it says here, but you probably can't read it very well, huh? What the hell is this? it copies the MDC from the thread submitting to the thread running. So technically, these lines runs in submitter thread. This line runs in worker thread. All right. Now there will be another talk with Anna, my friend, and someone else about virtual threads and scoped variables, such a concurrency. You won't have to do this with scoped variables if they ever come, right? They keep changing the API. But until then, when you come with a thread and you want to fork some more threads to work for you, virtual or not, you have to be careful to copy this information from the parent into the child. Technically, I'm not precise here because if you come from a virtual thread and you want to spin 2 more virtual threads, there is something called inheritable ThreadLocal that is going to copy your information automatically on the child threads you are spawning. If you are doing new thread, that's going to copy automatically. But if you are trying, like most of us, to put some work in a thread pool, this is the kind of code you have to write or get some tool to do it for you, right? So in other words, if I would submit my work to this thread pool executor, I would be fine in 2 reasons. This and this. Are we good? It will solve 2 problems out of 3. So let's do that. As far as my workshop or my discussion today with you, I'm about the queue size. So how do I inject that? Well, it's very simple. Done. What did he do? You see here, there is an overload of this method. Technically, you should almost never run methods ending in async without passing a second argument to these methods, which in this case is an executor instrumented and decorated by and controlled from the Spring, right? This is a thread pool that we just defined below there. Boom, this, here. Fun. So now, you see, you are spinning a thread from that thread pool, which has maximum 5 worker threads at once. So you are maximum 5 queue size. So if I refresh here like 9 times, I should start getting errors after that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. Saying, hey, I'm sorry, it's full over here. What is it? Async run, what does it say? Inactive state did not accept. It basically rejected my work eagerly. Are we good here? So we solved 2 problems out of 3. Good. Now, for the 3rd problem, the exception part, there are 2 solutions to the game. One would be to go here and follow up with exceptionally, and always remember to do that, my young new hire, said the elder. How would you do that? I know, you're going to create an open rewrite rule that will fail or add exceptionally for every time you do run a sync in all the code. That's actually a good one. Or a refaster rule. Or some custom IntelliJ. That would be a nice suggestion for an IntelliJ inspection. Hey, you are forgetting to catch and log the errors. Are you sure you want to do that? I want this yellow in front of me, really. Good. Now, let's solve the 3rd problem, the one with exceptions, the one we're discussing. Well, instead of doing this, if you're trying to fire and forget a task, what I would recommend you do instead in Spring is to do this. I'm trying not to turn this into a Spring discussion, but it's hard. It is. Who uses Spring? Spring framework. Ah, there you go. For 80% of you. So if you do that, now the exceptions that are fired, let me put back the bug, are going to be automatically logged because you say, I want to run async a void method. So there is no way you could get back the error into the caller. So when this fails, the error gets logged here. We are safe. We are good. Are we clear what you see in here? Are we good? Are we good? Right, let's see if I'm on track. Yes. Oh, and for one last point, there is another a problem, another bad practice really here. Besides this madness of submitting asynchronous things, there is another bad practice, which is, no, not exceptions. No, so there were 3, let me show you the conclusions here. There were 3 problems here. First of all, we discussed about common pool being unbounded queue and no lifting on ThreadLocal, and also competing with other compatible features and parallel streams inside the same GVM. We discussed about exceptions getting lost. So we used what? We used async. And then the bad thing, the stupid design that you played in this game is that you kept 10 megabytes in memory until a worker picks it up to do it. Well, that's stupid. Now really, if you were in your own comfort back home, thinking about how to design, I'm sure it wouldn't occur to you, oh, I have 10 megabytes, let's keep it in memory. I really think you won't come up with this solution. You're my great architect. I'm gonna keep the file in memory. This is not gonna happen, right? So you probably want to fetch the data afterwards in the worker thread. When you get onto the work, to streamline the data and not keep it in memory. But if you can't do this, if the data that you have to retrieve is retrievable now with some tokens that you have to propagate access tokens, I don't know, in that case, you might have to fetch, or if the user uploaded you a file to process in the background, you can't just say, you have the file in your hand. So what would you do to solve this? I'm not going to code it. It's obvious what happens. What? Save it. Save it somewhere out of heap, right? I'm going to go old school, files. You don't have files because you are cloud ready? Okay, in some Mongo. You don't have Mongo, just don't choose Redis. Let's put SQL. Well, I don't know. Maybe in an S3 bucket, save it somewhere and then pick it up later. Are we clear? Is it obvious? Get out of your RAM into some storage which can keep large bulks. Now, this gets very fun because there is a principle of streamlining. I plan to throw some ideas on you and then the break. Where are you? There. This is going to be horror. You will not understand half of them, but let's see. When you have received from HTTP, you copy the files on a disk on a temporary file. Does it make sense? Let's take it slow. Park it in some temporary file, and then you pick it up from there. If you click this link, you will get to a page showing you how you can stream 1 gigabyte from disk into SQL and back with no more than 20 megabytes of RAM. Now, why exactly do you want to send 1 gigabyte to SQL? It's another discussion. A lovely discussion you will have with your DB administrator. Large collections, you have a file on disk, you don't load it up one at a time, all at a time. You stream the files one by the lines in the file, easy for CSV. You stream the results of a database query. You will see this in the next half of the presentation, right? You can query and fetch an iterator, you will see. You can iterate through elements of a humongous, I have a client sending 1 gigabyte of JSON over HTTP. Why would you do that to someone? But it's fun what those are doing on the other side, right? So it turns out there is a fun new line delimited JSON content type you can use in your response request. And then that is going to stream over HTTP JSON fragments like element by element. And on the other side, there are toolkits that can parse them as they arrive. It's a sort of he's pumping elements, you're going to inflate them on your side, right? Kind of a reactive thing, but not really reactive. You can do it without reactive madness. Iterating through elements in a large XML file, right? Banks in the house. Any banks in the house? Banks, banks, banks. You receive the end of the day payment XML. All the payments your bank has done through Visa. It's 10 gigabytes, zipped. How the hell do you parse? I'm exaggerating. Deflated these 10 gigs. How do you parse payment by payment, right? You can't load them up. So there is a fun link you can click here to show you how you can iterate the elements in that huge XML without loading the whole thing at once. You can stream lines from Excel. I mentioned banks, so they should be there. Huh? Generate a PDF of 100 megs. Not keeping it in memory, they just click these links and get you there. And of course, the good old pagination of data. You take them chunk by chunk by chunk, and if you really want to get old school, you can do Spring Batch for maximum throughput, right? I optimized the flow 6 times using Spring Batch, parallelized, very fun stuff. But this all has a problem. How do you flow control the publisher, the one pushing you data? So there could be, if you really want, like, I'm not going to pronounce this. If backpressure is something for you, use this. And go to church. Pray. Good. Done. It's time for a break, and I'm going to be brutal for you. I'm going to give you exactly 10 minutes break. So 10 minutes break. Go. Oh no, I'm live. All right, guys. So what is wrong in this picture? 1 second. Go. What is wrong in this picture? The guy wanted to run in parallel 2 calls to network endpoints. And, there's something yellow. Perhaps IntelliJ would help us this time. Let's see. Lambda can be replaced with method reference. Yeah. Probably that's the problem. What is wrong in this picture? Timeout, no. Live thread for each request. Why not? Not efficient, you say. Exceptions and cancellation do not propagate back. Long live structure concurrency whenever that comes. What else? Finally. 5th answer. Nice. So let's try. Refresh. Click. And if you look at the heap right now, I'm going to try to refresh the page in the left while you look at the heap in the right. I'm refreshing right now. And the heap doesn't seem to grow much. Not a big deal, right? So nothing really seems to actually dropped. Ooh. But remember, until you perform GC, you can't really tell. 34 megabytes. And because I can't believe it, let's call a friend to hit it harder. Okay? So I'm going to do this. Let's start small. Let's hit it 5 times with requests. I'm going to call. You can see a bit of heat here. If you perform GC, however, 68 megabytes. If you heap dump, no huge didactic example of memory occupied, and retained sizes show us what? Show us nothing. Retained sizes show us nothing. Actually, the entire heap doesn't seem to grow that much. Right? Actually, it did. But where is my leak? What exactly keeps this memory? By looking in the heap dump, you don't seem to find anything fishy here. It's not big. These are no clear suspects. Guys, in this picture, where exactly is the problem? Let me give it more heat this time. Where here? Threads. What with the threads? Live. Oh shit. Oh God. Oh God. Oh God. Oh God. And by the way, RSS, strange name, stands for resident set size, which is what the operating system sees of your process. So you see here the used heap is 60 megabytes, the blue line we kept looking at, but the process RAM is 500. Ooh la la. So the problem is that threads don't live in the heap. Threads live somewhere else. So it's time for what should have been the first slide. Java has a bunch of memory spaces. There is heap, in which you allocate your objects. And there are threads that are basically the thread stack, the stack frames. The methods that are called on top of each other per each platform thread, taking up to half of megabyte each, times how many threads, platform threads you have. We're talking about the traditional threads that we use, new thread, right? So you see here, the memory occupied by these is proportional to their number, each keeping between quarter and a megabyte each thread. You can change the stack size with this parameter. And so this is where the threads are living. This is what just inflated now. Agree? Not the heap, but I have thousands of threads taking each memory itself. Now, there is also metaspace. I don't have a demo for this prepared, but I will sketch something in that regard. And native memory. We're going to touch about these two later a bit. Now, besides these, this is where classes definitions are. And this is when C++ or buffers, I'm going to get there later. And then the heap, right? And the heap is subdivided into young and old generation. You get born in Eden, pure and angelic. And then if you survive your first GC, you're going to get into the Survivor 1, and then you go to Survivor 2 a bunch of times until you get promoted into the old generation. So you may have heard of this idea that there is young and old. Young generation is cleaned by minor GC, and everything is cleaned by something called a full GC. The thing is that minor GC runs very frequently and is very fast, whereas the full GC, here is where the corruption is. I'm not sure if this joke stands here, but we have in Romania a political party in which everyone knows everyone. And there is a department called anti-corruption department, and they try to garbage collect some of these guys. It's impossible. They're very intertwined. They just tried to reduce the salary of the judges. How do you reduce the salary of someone that makes the laws? They're trying to do this for 3 months. Anyway, it's very hard to get that untangled, right? These are where the singletons are, the cachers, the resource pools, full GC. Good. And this is basically, and there is also a string common pool. The literals appearing in the source code are statically loaded in this place and referenced from all over the place. And the virtual threads keep their stack frames, very tiny, but they are here. And the stack frame, sorry, my reflex, I have this obsessive compulsive. I cannot, this is about 1 kilobyte per each, n times, 1 second, n, I shouldn't be doing this in Deadlocks, n times 1 kilobyte each, so it's super light, and those are staying in the heap. Out of memory can occur because you run out of heap, because you run out of, can I get an out of memory? Right, that's more fun. Let's try to hit it harder. Oh, one more time. One more time. I had that once. Anything? Process is still alive. Should I hit it harder than that? Let's see how big the activity, how big the process is. 19922. This is going to be ugly. 19922. 19922. 600 megabytes. Okay, can I give it more heat than that? 200. I'm at maximum throughput. I just have to wait, and I don't like waiting. But this is gonna grow big. I'm not gonna waste your time on that. But the point is, here we are leaking threads, and I'm not really keeping any heavy memory associated with that. I'm just leaking threads. So how to fix this? You said, repeat, somewhere there. Close the pool. So let's close the pool. I am gonna close the pool. Ladies and gentlemen, I am gonna close the pool. Pool. Dot shutdown. Am I good? Well, technically, scientifically speaking, it should be a finally, but really the chances of those blowing, actually, who knows? So let's be safe and basically do this pool and say, try with resources. Lord gave us try with resources for exactly this reason. Done. Boom. And now the pools are closed after each call. Okay, but somewhere there already said something, hey, but I'm creating new threads for each call. That's a bit of a waste, I know. And that's gonna now hurt on performance, but as far as memory leaks, we're kind of, there is another, but no, I was waiting anyway for the results. So I was waiting anyway, but forgetting to shut down. Fixed thread pool does this for you. If you specify 2, you get 2 things. You get exactly 2 forever, and you get something I love. I love this. That, love. In memory leaks, that gives me a job. Right? The problem is these threads will never die. That's the thing. Those threads will remain active. All threads will remain active. This is something very old. Where was it? Since this is like Java 2, something very old. All right. So how to fix this? Parallel what? There is a parallel executor. No. Virtual thread pool that can free threads. Free threads. That's gonna work, and then you don't have to. That's actually very good. That is a solution to this problem, a new age solution. You can just say here, virtual something, virtual thread pool. Exactly. Free for all. Free for all. Take them. They are cheap. Free. Fire in the hole. Spin them all. Fun. Many threads. Millions of them. And that indeed does not leak any threads anymore. Should we try that? That's not, I didn't try that beforehand, so let's give it a live demo. That shouldn't cause any issue, right? No, the virtual threads will die in peace. So fire in the hole. I'm gonna reconnect to the application. Yeah, but JProfiler costs money. I have to show you. I don't want to sell anything today, just concepts. So here, and I should be stopping and asking how much residence set 348. That should be left more on in the oven. But wait, I have virtual threads. Am I running? What the heck is this? I'm not gonna debug. It's gonna be a waste of time. But virtual threads are a good call on this. All right? Or I could, if I want birth control of how many do I want to throttle somehow, maybe I could use a thread pool which is shared for the application, the one that we've seen previously, right? So that is a good call. I like that. But I'm going to demo another one. Let's go completable future dot run async. No, this is supply async because I need something back. But then you remember what should come as the second parameter every time? The executor I have carefully constructed. Done. Now, of course, all of them will tap onto the same pool. This would exhaust the pool. It's a bit risky. It's not going to scale very well, but we can tweak on that later. We're good. Is this example clear? So fixed pool, not closed, dead. Good. Right. Let's do a restart, and let's reconnect again to see. One more. Let's see. Let me give another dose of hate to virtual threads yet. They are super fun, but they have some weaknesses. Let's see if I can show them to you. Ever heard of a deadlock before? Ooh, hardcore stuff, senior stuff, the stuff that I usually call John for. You know, John is an old guy, gray-haired. He knows well about Java. So I go to John every time I have a problem with some deadlocking thing. Let's start small, let's start easy. Before I enter, I want to enter traditionally with no virtual threads in the house. Good old style Tomcat thread pool 200. So because I can't show you the basic example in Deadlocks, like you are among the best in the world, so I can't show you that. So instead, I will take you to the pro memory deadlock. What is the problem in this picture? Where is the deadlock? Let me hide the irrelevant part. Oops. Just made a mess. Let me hide the irrelevant part. This, for now, is irrelevant. And if anyone gets the point, shout at me. There is a synchronized map to two of them. Okay. Okay. Continue. This is a new age deadlock. First of all, some of you probably are stuck in the compute method. The more seasoned of you are like, huh? Is there a compute method in the map? Where did this came? What is that? And what does it do? Well, it works with the old key and can compute a new key if there was one already. And this compute is a method of a synchronized map. Continue. So the lambda executes in a synchronized block on map A. So before you entered this lambda, you already took, let's draw a lock here, the lock of map A. So by the time you enter this lambda, you have the lock of map A. And then over here, what happens? Am I trying to get the lock of map B? Yes, you are. What can go wrong? If someone writes the exact same line, but flipping map A and map B backwards, boom. And guess what? That's exactly what happened. Someone just messed up these two, they put them backwards, and kaboom. Right? There is no synchronized keyword in the house, there is no reentrant lock, just good old synchronized map. Actually, there's this word here. But the point is, it's mysterious. It's lambda running within a synchronized block. This is what makes it so evil, right? So it turns out that synchronized map executes the lambda into a synchronized block. God damn it, so lambda's running with locks and acquiring other locks in the IHA. Good. Guys, I'm just trying to impress you here. There are easier ways to do these things. For example, Redis lock A, then B, and the other guy does backwards. Or, my favorite, you Redis log something, and then you select for update in Sukili. And the other guys do backwards. Right? Or the good old synchronize, calling each other. I'm not going to spend on that. I'm just telling that if we play this exercise, boom, the messages should be relevant here. It says refresh the page, then call to within 3 seconds. Ooh. So I should call that and then refresh me. And please enjoy one of the most annoying signs in the world. There are 3 of them. This, empty battery, and no signal. You know, there was a survey. Which sign you hate most? This, freaking loading forever. But something fun just happened right now. Anyone ever trying to acquire the mutex, the lock for any of these 2 maps is gonna freeze forever. So let's try to call it one more time. Now there are 3 annoying signs in the same screen, all stuck forever. What's gonna happen if I try to call it 200 times? Are you with me? Are you with me? Fire in the hole! Done! Now, if you go into the memory app and if you go to threads, you have to be stupid not to see it. The advantage here is that the deadlock occurs between 2 synchronization primitives within the same universe. Java can tell this. Databases can tell. Anyone got a deadlock exception from database? Database knows if you lock things in the wrong order because you are in the same universe. But if you mix Java, if you mix Redis with database, or your own synchronize, if you want to have what to debug tomorrow, do that. Mix 2 universes, Java with Sukili, or Sukili with Redis, or Redis with, boom, you're dead. If you get them. Yeah, you don't know this? I see you are not aware about how to pronounce. But you can't hear. You should just Google for this. I didn't plug the sound of. I should have. Anyway, the point is, you now see blue. I see blue. Ooh, somewhere over the rainbow. Lots of blue. And I wonder now. If anyone ever asks me how well I am. Now this is your chance to survive this, guys. What would Kubernetes do if it sees you say nothing? What will do after 5-10 seconds? Kill you. Oh, but that's good because you have one more chance. Yeah, it's going to kill the instant start and that's going to be a lifesaver. But you know when really things are the most fun? When you block 198. If you block 198, you are left with 2. So any request you send, until you deadlock the last 2, you're gonna have a very bad response time. Okay? Okay, good. So this is fun. Any heap dump you take or thread dump you take is going to show you clearly at the end where the problem is. There are 200 threads, and this is a free tool. It says at the bottom, I promise, it says, I am hooked into that, and I'm waiting for that. But just like with good old Windows, every now and then, you have to give it one more shot. So a clean restart. Remember the days? Visual VM. We had to restart Windows once in a while to be good. All right, so, okay. So where is the leak? Well, you do realize that anything you kept in the methods that you were running accumulate in memory, correct? So if you were doing some nasty processes that made use of synchronized things, you are now stuck with the request payload, whatever you had in there. But what will happen, I wonder, if I go to application properties and enable virtual threads? What will happen, I wonder? And that's some kind of a new demo I want to try with you today. Well, if I go virtual threads, let's go to homepage first. Good. Let's go to this pro level thing. Click. After 3 seconds, it will work. But then if I block the 2, boom, boom, then, oops, oh, my bad. 1 second. Click here and refresh here. Done. Now this should deadlock. Now guys, what is the biggest problem with virtual threads in Java 21 that was fixed in 25? Thread pinning by synchronized keyword. Okay, so let's keep refreshing. Localhost. Let's keep refreshing. 1. And in the meantime, I'm going to look in the threads that happen. What happens with the threads? Now, you may know that the virtual threads are by default running on fork join pool 1, not common. Virtual threads run on these things. Now, let's keep refreshing this a bunch of times. Click, click, and your eyes should be here. Am I seeing anything strange? Not yet. I did not went 200 calls, but I wonder if I go to localhost, does this still work? Yes. You're fine, says Spring Boot. You're all good. There's nothing wrong with you. Because that's just one more virtual thread, correct? That's responded you, I'm good. So now let's give it some heat, shall we? But since we are using virtual threads, let us rain hell on it. So, cool. Now, the nasty thing that you're going to see is that right now, this free tool doesn't know to track the, can't tell if your GC root is a stack of a virtual thread. I'm speaking so, if Mama saw me speaking so complicated words, she would be impressed. So heap dump over here will not, you cannot see where the problem is because virtual threads are not really fully supported by this free tool. There's nothing fishy here, right? There is 180 megabytes of heap that you cannot track what it belongs to. What it happens underneath is that there are virtual threads. Studying hard, I found one day a way out, but I don't remember exactly how I did it. There is a way to see virtual threads, each blocked in that same synchronized, keeping, wait a second, I think I'm doing a mistake. Am I running this on Java 20? Am I running it on 21? Yes. There was a difference. I was able to show, but again, this discussion is about memory leaks. There was a difference between how things behave. To be perfectly brutal here, if you enter with virtual threads here in Java 21, when they will hit the synchronized keyword, the virtual thread is going to pin along with the underlying platform thread. So it's going to basically destroy your entire application at some point. In Java 25, that synchronize keyword will just let the virtual thread park there, and then go on with their own stuff. I think I can. So in terms of memory, the next bottleneck once you step on virtual threads is how much stuff you keep up there. And there's something else that annoys me. If I connect to this application that has thousands of threads blocked, there is nothing warning me of any deadlock. Again, tooling is not perfect yet. Free tooling. Good. Right. So next game. This is, again, a story from a client of mine. They were using some old library to do some work. But the bad news is, again, the library is in a jar. Almost always the memory leaks occur in some old code base you don't have a clue about, or some legacy library that you're using. And they were using some old library designed in the early 2000s to be used in a desktop, swing, console, or job. The kind of applications we do not deploy in cloud today. So, in their do work, they've created some data they wanted to clean up after. And you know how they made sure they clean up? By adding to the runtime a shutdown hook to clean some files they had on disk. This was the real story. They were creating some temporary files on disk, and they were adding this runtime add shut. Who of you ever heard of this before? That's like 20% of you. When I went to my client, I was like, what the heck is a shutdown hook? I never heard of that before. It turns out these are executed by the JVM just before it dies. Do you see any problem in here? Sorry? It might not be executed because this is a web application that never shuts down or very rarely shuts down. So if you keep this on for 7 days, it crashes. So what do you do after 5 days? You restart it. Who let the dogs out? After 5 days. Who let the dogs? Nice. Good. So what is the solution for this problem? But the first thing that you should say is, Victor, can I go to runtime, Java lang, get runtime, and basically I can remove, but how the hell do I get hold of the object they've submitted into that collection? I can't get hold of this new thread. You can't get it out. So there is no way I could remove the shutdown hook from there. So what did they do? Boom, clean hooks using reflection, clear hooks. They actually went into the GDK. Oh God, does this work? This is so sick. Sounds so bad. I am making accessible a field in Java lang. This is not going to end well. This is not going to end well. For sure, it's not going to end well. Close other tabs. So let's try. Where are you? Boom. Indeed. Unable to make ChatGPT told me afterwards to add this to my JVM arguments, and it works. Edit. Beautiful. Not this one. Memory app, yes. This one. Edit. And done. There is nothing an engineer in distress won't find. Run. Right? So, done. No, really, technically, you shouldn't just remove them. You should execute them, basically. Maybe every night, or sometimes when it's out of load. So now you're good. I forgot to demo the leak before I fixed it. The heapdumps are all in that place I shared with you, and I will put again on the screen. Is it clear here? So this is an unbounded collection. Beautiful. Beautiful. However, next exercise is the best. I mean, it's one of the most mysterious. This causes money to leak. Not money to leak, memory to leak. And therefore, your boss has money when you spin more instances because you're out of memory. Where is the problem? Maybe what does this do? Nothing. Look, I promise, nothing. I promise, there's nothing fishy there. It just prints some string. Nothing. So where is the problem? No clue, huh? Reload. Really, there is nothing you could tell me looking at this method, but you should be thinking, I'm transferring money. Ooh, an API call transferring money. I did, yeah, for a demo. Don't do that with a get. Of course, not a get. Sorry. Yes, don't use get. So the point is here that calling directly the endpoint tells you that you are missing a request header called idempotency key. Anyone knows what idempotency means? Too few of you. Attend tomorrow in my workshop about event-driven pitfalls. Idempotency key means that you will add to your requests a different header every time so that the other side knows that you are retrying and not trying to transfer again money. Make sense now? So let's see this in action. I'm going to open network. Let me increase a bit the size. Good. And I'm going to say if I call it without header, it gets rejected. If I call it with the same header, this is my idempotency key. Where are you? Idempotency key, same idempotency. If I call it again, first time it went on, it went correct. If I retry with the same idempotency key, where was it? Here. Then I will get a reject, correct? From what endpoint? From this endpoint. What the heck happens in here? It gets rejected every time. But if I call it with a new idempotency key every time, if I call it with an idempotency key every time, a different one, it accepts my calls. Do you follow the idea? It's a way to deduplicate the calls on the server side. But where the heck is that? So, true story from one of my clients who's building a core banking product, sold to banks to do money transfers. What they do, they had such idempotency protection. So refresh. Let me first enable it. By the way, the JMeter project is also in the Git for you to play with. So right now I am calling it a bunch of times, and let's see what happens with the memory. Nothing seems to go wrong yet. Okay. Perform GC. The leak, if there is one, is very, very little. Someone said the cache. Someone said the cache. Exactly there, that's where I'm going. Let's heap dump. Let's hope that we captured the problem. So I'm now. It is a free tool, but wonderful tool. Idempotency filter. Who the heck is idempotency filter? What is that? Said the new hire. And then he found this, who happens to intercept exactly our endpoint. And if you go exactly to this endpoint, they would require you have an idempotency key. If you have an idempotency key, that idempotency key must not be in the list of previous calls. Is this a collection in memory with no upper limit? Yes. But we restart the application every day out of business hours, and it works. So do not retry to transfer money to some guy you know exactly at midnight with this bank. There is another dark story here, really. To be honest, this is silly, because what if you have multiple instances of your application? This is in memory of a single. Yeah, but we partition the customers by their ID modulo 3 to do routing on a specific instance. Okay. Have you heard of Redis? No? Okay. Okay, so we are working with this code. We have to fix about this something. So, and I have here a fix me left by someone many years ago. That's a to-do, right? It's a to-do from 2020. Clear every second calls after, and I feel like vibing today. Do you feel like vibing today? Let's vibe. Let's see. Okay, good start. You're good. Come on. Let's try. That's the beauty about AI. You never get bored. Every time different shit. No, but the problem is the context is not enough. How the hell, I'm thinking, the dog now thinks, how the hell would I know which are what? I will help you. Long timestamp. So I need here to, good dog, good dog, good dog. And now dog, do you know what to do? Yeah, there you got it. You got it. You got it. Scheduled. Scheduled. Where did you get that from? Scheduled. This is how you scare a senior. You show code generated by AI. Does this work, boss? The senior goes like, I never saw that before. What the heck is that? A shutdown hook? And so on. So every second you're going to look in there and remove. Will this work? Well, I did clear the data, the data in the list, right? Every second it ticks and it clears. I will show you. It should start ticking if I restart the application. Let's see again. Come on, come on. Every second. No? Let's try to hit it here a bunch of times. Call it. Something is wrong. Oh, I did not log info. Come on, dog. Good dog. For logs is a good dog. Very good dog. For logging, perfect. Human-friendly, good dog. Beautiful. Beautiful. Refresh, but let's call the friend below there. I fired the load. And now you can see here, idempotency key is accumulating and being cleaned after a bit. Let's see, look, decreasing. Have I fixed the performance problem? Let me put all the, I will collapse here. I think I'm done. Let me hide the stuff, it's irrelevant. And now I will ask the seniors in the room if I'm done. Why am I fired 1 month after? If you retry after 3 seconds, so we now have to have a contract with the client telling them you shouldn't retry after 3 seconds. How do you do that? Good point. So let's be more generous here, but this is not why you're fired. What did we do? Guys, I rushed you a bit. I know, I'm guilty. Do you see this add call? This add call by the documentation adds the specified element if it's not already present. So what did I do right now? I am adding a new call with idempotency key and timestamp to the set of previous calls. Why am I fired? It will always be new. I will never collide anymore. Let me demonstrate. Remember, this button should fail after the first call. That's the whole point of this idempotency thing. Let me retry. You are fired. Or you have to pay for the $200,000 of retries that the mobile application did while people were in the tunnel and trying to transfer money. True story. Okay, so then we need to be a bit more careful here. You can't just add like this. This gets dark, and it's not the place to do this today here. But the idea would be to go something like, am I having in the previous calls non-match this? Again, this is now gets into this leads to a performance problem. When you start cleaning, however, no, it's good. Okay, but then you have to add previous calls.add of the call that you want to add. And the problem is there is a bit of a race condition between these two methods. The story gets dark. I'm not going to solve it. I'm just going to warn it. There is a bug here. There is a possible race condition. But that is the way to... So the story here is that I had the performance problem. I tried to fix it, and I got fired. Could happen. So very, very dark, because there is usually risky code, legacy code, dark stuff. The leak is there because the code is complex. So be very careful what you're doing. All right, fun. Let's see more. Let me restart the app to start clean. And I think we're going to reach my favorite. Yes, caching. Beautiful. Time is, we have less than an hour. I think we're good. Let's first see how can I leak with a cache. Come on, start simple. The most idiot, naive, childish. What is the most simple way to leak when trying to cache some data? Never what? Never clear, never expire, never evict, and don't put a max size, but instead create a cache of your own, a manual cache. Beautiful, beautiful. And I'm using the fancy computive absent. There was this phrase I once heard, "Dear manager, you grant me time to play or I will push it to production." Beautiful. So they pushed it to production because I didn't have Slack time to play. Hey, look, computive absent. I never used that. Let's try. And this is so stupid, not to mention that the actual call happens in a synchronized block. This is a crime. You're throttling all the calls out to a single thread. Damn! Boom! You're fired. No, you're not fired. What should I do? I've seen these cases, and they told, hey, the keys should be limited. You know that phrase? Ever heard that? The number of keys we keep in the cache should be limited. We love that. The number of keys in this naive cache should be limited. Okay, but I don't like this should. So what you should do every time you have a class that should, what is this? Metrics and alarms in production. So there once was a dev, and that dev met an ops. And what they became together after a one-night stand together? DevOps. I have a theory that once you have a midnight incident in production, when you wake up the next morning, you are a different developer, in a different league. You are in a different universe with the rest of us. You're going to be logging all the way. You're going to be tracing, alarming. You're going to do MDC, open telemetry baggage stuff that the other colleagues won't understand what the hell you're talking about. That traumatic experience is going to change you. So I wish you all a midnight production. No. Now, what we should be doing here is to freaking use a professional cache. So, cacheable. Huh? What is that? I'm trying to fix cache. And then I'm going to call a friend. I'm not going to do this anymore. Boom. And boom. All right. But by the way, this does get already pushed. If you go to the metrics, you're gonna see here, this already logging how much cache size you have in there. I'm missing more things. For example, cache miss and cache hit ratio should be there. That's why I'm switching to a professional cache. This fixed cache I'm defining, this is a bit prepared in advance. I'm using Caffeine as the backend cache provider, and I've defined a bunch of cachers that I'm going to be, hey, what is this? I was looking for you.
Hello,
Nice.
is it me you're looking for?
Beautiful. Beautiful. Right. Now, the next question is 50,000 isn't too much. No? So, but we have a, right? We have a knob to turn. We have a config to set. Perfect. So that should fix it, but for the sake of argument over here, let's first reproduce this stupid leak. I think the code running right now, I did not restart, exposes the leak. So I'm going to just refresh this a bit of time until with different dates, of course. And the memory gets crowded. And at some point, if I'm lucky, I can actually, this is like, you know that game that you have to hit something popping out of the, and yes, it's dead. Perfect. Just happened to us. So if you go there and if you say here, let's say maximum 5, I'm going to be brutal for demo. Now that I'm deploying with cacheable annotation and no more your own, not my own stupid cache, then if I try to at some point it's gonna stay put, you see? It doesn't grow anymore. Of course, it evicted the older keys. Easy. Okay, that makes sense. But let's see then the next one. But now, I tried very hard to make this happen, but it's very, wasn't able. I failed. I wanted that when I see here Git history, I wanted to have someone called vibe coder to have changed this method just before Deadlocks to add this parameter to the method. So imagine that when you git blame this line, you find the last commit coming from vibe coder that he just added the request time in order to be able to log it in here in the log debug message. Cache key. And by the time he added the request, when he added the request time, the cache key of the cache behind is now including the timestamp, which is every time a new timestamp, of course. What's that sound? Well, the production won't fail, but we will have a cache hit ratio of exactly 0. Because what Spring does is when you annotate a method with request time, my video stopped. Okay. When you annotate a method with request time, it adds this to a composite key that it resolves into caffeine, right? That's the reason why some clients of mine have banned the word cacheable from their code base, saying it's too much magic. That we want to be certain about the cache access we do, not just, oops, a new parameter, boom, it's too magic. At which point you should ask, Victor, when the vibe coder did that, didn't any test fail? Who in the room has a cache? Keep your hand up if you route a test for that cache. Like 60, 70% of hands went down. We saw it works. And then he comes and vibes in your code base. We have to be prepared for the vibe tsunami. Good. Next one. What is wrong in this picture? Lombok is not bad. It's just making code fit the screen. The object I'm using as a parameter, as a cache key, is not a primitive. It's my own type, and my own type is missing what? Hashcode equals. Hashcode also. Vibing, good. So the correct answer is that it's not that I'm using Lombok. No, I'm using too little Lombok. Or even better, value. And if I'm there, what the heck stops me from taking it into the next level? Record. Done. So yes, you're right, Lombok. Never mind. Java did survive 2025 thanks to Lombok. It's too much to say? Too much to say. Good. Who uses Lombok in the room? I'm so... Oh, look around. Like 80%, maybe 70%. Fun. Are you looking for a bank? Good. So inquiry params, done. Let's do the next one. This is a bit darker. Now, who here knows GPA, Hibernate? Raise a hand. I will test you on this. Again, the last commit comes from a vibe coder saying they prompted me to save it. Okay, and I've saved it. I'm going to try to fit all the code in one screen. Let's see if I manage to. This is hard. This is interview question. Again, we are playing this game, but the game is easier in real life because you have cache hit miss ratio. You're going to have this cache with a hit ratio of 0%. Can anyone tell me why? No, no transactional. That's not the problem. The ID, speak up. What's wrong with the ID? Continue. The ID that Hibernate assigns to the object when you do save gets set to the new ID generated from sequence, from UUID, from wherever. So technically, by the time you exit the function, The inquiry contains every time a new field. You enter with null ID, but you exit with a brand new ID. God bless you. But in your cache, we have every time a new ID. Cache miss, cache hit 0%. Guys, this is freaking hard. It works. I can demo this. Let's try. Mutable key. Let's start from scratch. Mutable key. This is freaking insane. Freaking insane. But exactly what am I gonna see? Let's give up on the. Oh my God, the battery is dying. This is unexpected. This is stupid, because the wire is there. Thank you. So let's make a mess, huh? Put many keys. But I am in my code sending the exact same value originally, the inquiry. So when I'm doing save, I always work with the exact same object. Do you see? So normally the cache should grow only up to one element. So let's hit it. This one was mutable key. I'm getting lost. The names are bad here. This is one I'm testing. Yes, mutable key. This one, mutable key. Refresh. Epic fail. Okay, so how to fix it? Exclude the ID from the caching. That's one idea. Let's make some more space here. Move save out of the cache. So you add it in the cache in a way, and then you save it and you work with it, you do whatever. Will that fix it? Let's try. Oh my God, you made my day with this idea of yours. Beautiful. I don't have to show you the next leak. Let's see. Epic fail. What's wrong now? So imagine, close your eyes and imagine that over here, let me just make the code more compact. Over here, right? Over here, the cache, the map behind does a put with your inquiry and some data. It's the same object, so what? After you've put it in the cache, you change its ID. If you put in a hash map, an object, it will land in the bucket according to the hash code at the time of you adding the object. But then once it's in the bucket, if you change the fields on which hash code is computed, next time you might actually never see it anymore again, because that object was added to the wrong bucket. Do you see what I mean? If you come with the next object tomorrow with the same initial state, you're going to look in a bucket, but then if you equals, you're going to find an object with the ID set. And they will never be equal to each other. This is so dark. Probably half of you are still wondering, what is he talking about? His lips are moving, but what the hell is he talking about? I'm going to try to explain it in voice here. When you add the object to the hash map behind, its hash code is computed on the value without the ID assigned. It gets into a bucket, but when you call it again, next time, you will be looking in that bucket, but remember, the first object was assigned the ID after. So, although it is in the proper bucket, equals will never match because that one in the cache has an ID once your new key doesn't. That's a very hard diction test to try to do this. This is insane. I'm sorry. Good. So, are we good with caches? Are we good? Are we comfortable with them? Did we understand? So, the problem is mutable. Mutable. The cache key should not be mutable. That's the problem. Otherwise, the cache can miss your stuff. It got too dark. Let's move to the next one. There is an awkward silence. It's like, what is he talking about? We are here to have fun. What is he talking about? So let me show you some fun. First of all, the example of code is already a bit on the edge of X files here. Have you ever seen a query bringing a stream? I mentioned before in the streamlining technique to read line by line from the table without loading the whole thing, because the whole thing is too big to fit memory. So if I now persist the data, I've just inserted 600 megabytes. Remember, I only have 500 megs. So if I try to load everything up in memory, it will crash, correct? So to avoid that, I am streaming a query from the repository. That's going to force you to keep a transaction open so that the connection stays with you when you consume that stream. Dark already, but I'm playing Kung Fu style here, right? So let's try to export. What happened? Beep, 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 dead. What just happened? Out of memory. Ooh. Let's take this hashprof. Let's load it in the profiler. Home, load, paste, done. Let's see what retained size, what is big in this. Ooh.
Ooh, what does this button do? Please.
Hibernate ended up keeping all the data in memory. That's unexpected. What exactly do you keep in there, my dear Hibernate? And where is that data? Can I see this, please? Let's see. They can definitely improve on how it looks here. But the idea is very strange. We have here some byte array containing a. What is this? This is a. So let me ask you first. Perhaps some of you knows this. What's the problem in front of you? This is my piece of work. It broke in staging just before production. This close to get to production, to slip this to production. What is wrong in this picture? Come on, half of you, more than half, know Hibernate. What is wrong in this picture? All the lines, all the entities are in memory. Why? You keep saying transactional. Okay, I'm going to comment transactional. I'm going to play that. Come on, let's do this. Well, it fixes the problem. Let me show it. So I'm going to persist the data and then export. Boom, yes, it fixed the problem. It doesn't work anymore because you're trying to stream a query without having a transaction that keeps the connection open so I can traverse the result set behind the scene. So I have to have this. In desperate measures, I tried to have read-only, it's true. It still fails. Can you speak out a concept that we are stepping on right now? What are we really looking at here? What's the name for that place that keeps a copy of all the entities Hibernate gave me ever? Persistent, first level cache. I do have to tell you a story. I once interviewed for Adobe, shouldn't say that. And their first question was, how do you tune second level cache of Hibernate? So I just came into their office. Their first question, how do you tune second level? I didn't know what first level cache was. They were asking me how to tune second level cache. What kind of an entry question is this? Are you trying to see if I panic? I panicked. Good. So the read-only, this doesn't work. It still crashes. Exporting, boom, dead. So how to fix it? This is really dark. So the idea, the first level cache, that's exactly what we're looking at, keeps a copy of all the entities Hibernate gave you in case you find YID again. They give you from memory. So in order to remove an entity from the persistence context, the only way I know of is doing detach. Ooh, now this is getting dark, isn't it? What the hell is that? basically forget about this entity. Don't cache it in the first level cache. And now, yes, you can export tons of memory with very little RAM. Does this make any kind of sense for any of you? Wave a hand if it does. I'm gonna remove it from the first level cache. So persist, and then export. And now, fortunately, it won't break. Exporting logo, this is the schedule. Export completed, oh my God, fun. And it says, I've exported this more than 500 mega that I have heap into that file. Are we good with what we saw? So it's a leak in a framework you're using. And this is where the normal leaks that we run into in normal backend today end. But there are more. Anyone has ever heard of a Classloader leak before? Classloader leak. So you've lived the days of WebSphere, WebLogic, JBoss, like a boss. The days before the cloud came, before microservices, before Kubernetes, Docker, the moment in which we were deploying multiple WAR files, you know, there was a fun, I think Spring Boot coined this, make jar. We should tell Putin this. They make wonderful jars. Anyway. So in the times of the Great War, maybe some of you remember better year. Yeah, enterprise. Huh? We used to load, unload applications into the same Java process, host process. Now, this example is very contrived. I don't want you to read everything. I will point you to exactly where I want to, what matters. This is Java code, which I compile into, I compile with Java C on the, why do I need this? I always wanted, honestly, to reproduce this memory leak, but now with Deadlocks, I had really the time to play on this, and I managed to do it. The point is, if I put this class into my own class path, my class loader would have fetched that. The actual leak happens from this. I am creating a new class loader to load a class, the bytecode of a class, from disk. So there is a .class in my project. I should demonstrate this before I proceed. When I click this, there is a class which just got compiled. It's here, plugin.class, this. It's not part of my target folder. It's not part of my class path. It's some other class application, var, year, plugin, whatever you have. In Eclipse, it happens. You know, it's GI. When you load jar files into an existing process, right? So that's what I'm doing over here. I am loading that class from disk or from a jar into my process. And what do I do afterwards with that? I instantiate the plugin, the class that I've just showed you briefly, and I add it to a list. What should I do when I load a new version of the same application or plugin? I've added an instance of that class to a list. What should I do now? Remove the old one. Oops. So the interesting is how it looks in a heap dump. That's where that's what's really mysterious. In the heap dump, you will find here these int arrays being held by instances of the same class. How to phrase it? Just a second. I don't find the proper way to show you. Maybe, let me show it again. I should view all. Yeah, that's it. What did I do? Free tool. View all. Where are they? Maybe. No? Yeah. But the point is, these classes, I should have started backwards. Let's look again in the source folder, in the source file. Guys, this is a static int array. Normally, how many of these can be at one point in time in a process? One. It's a freaking static. There are many now. Because I've loaded again and again the same class, and whatever they brought with it, it's still there. The memory leaks usually don't manifest by keeping heap, but by exploding the metaspace or parent gen. That's what you might have seen in your career. The point, I just want you to be aware of when this happens. When you have a Java process and you start with class loaders loading the additional code into your process. And the question, why do we need a separate class loader? Because you might really want to have different applications with the same class names. It will be really strange to collide with another WAR file in the application server 10 years ago if you contained the same class. Each had to have its own namespace of classes. That's the reasoning behind. So you create a new URL class loader so that class names do not conflict with each other. But then the class inside that, when you want to unload, you forget to dereference. Or the other way to run into this leak is to make the plugin start its own thread. If the plugin starts its own thread, that thread is going to keep the class alive. Does this make sense? Because it's a live thread keeping a class alive, even if there is no other reference to that class. That's even more mysterious. Let's reproduce these two. So here, I'm just saying start. And when I invoke start method creates a timer and schedules it with this class. So the class surrounding you, this class, can never die if while the thread is running. You have to first stop the thread in the plugin. Dark stories. I'm sorry for showing you this, but things are going to get even worse soon. So, all right. So again, you can find these classes being held by GC root by classes called plugin loaded by different class loaders. How to put it? Do you see this? It's a different class loaded by different class loaders. That being said, I really hope I will never have to demo this again in my life. So restart. Let's look for the next one. I have just two more, I think. This is very dark. So by some threads or forgotten references, an instance keeps alive the entire class loader with whatever other classes were loaded by that class loader. They will never die. What's left? Yeah, direct memory. This is very dark. The point is, back to the diagram with all the memory spaces. There is heap, there are threads. I do have until 25 more minutes, right? 24, correct? Just to be sure. Good. And there is direct memory that C++ code can use to write in. The problem is, these buffers over there, they do not show up in the heap. That's all I want to show you today. So look, in the direct memory, here, I've just allocated 10 megabytes of RAM in the direct memory, but if you monitor your heap, you won't see nothing. You see? There is no increase in the used heap. So that's the most mysterious part. You don't see it in normal metrics. You know where you see it? In the process RAM. That's your only chance. The process RAM would increase because of this native memory around the heap. Too dark, huh? Now, I have another one that I really want to show you, even if you don't like it. Yes, you are seeing right. You are looking at swing. Ladies and gentlemen. Swing. Boom. Boom, boom. Amazing. Oh my God. Oh. Exactly. A round of applause for swing. Rest in peace. Good. Thank you. That's the last round of applause swing ever got. The question is, how do you think I did that? How do you think I made the background colors of these divs change when I move my mouse on the parent frame? There is an event listener on the parent frame for mouse move, which tells all the windows to change color. Each window takes some megabytes. Let's connect to the process. So how there are right now 100, I'm exaggerating. This one, I went too far probably. 100 megabytes for each such window. So what should happen if I close the window? The memory should decrease. Let's close all the windows. Let's perform a GC. The memory is still there, of course. How it's still there? Because these interarrays right now are being held, although the frame is invisible, are being held by the, where are you? Event multicluster leaky frame. I will show you the code. They are kept by a listener of mouse movement. This is exactly the problem. I'm adding a mouse listener to the main frame, and then connecting in that mouse listener, connecting the main frame. Where are you? Just a second. So add, but no, it is here. So main frame gets added a listener, which listener keeps the new frames you've created, the 5 ones. Are we good? And even if they are shut down, they are still referenced in there. Very dark. And by the way, JavaScript can also leak. JavaScript, the language made in 5 days. Yes? JavaScript. JavaScript can leak memory the same style. We forget to deregister a listener and boom. Nice. But that's another discussion. Now, time for some conclusions and some wrap-up thoughts over here. So, how did we study heap dumps? Some lessons what did I do almost every time? When I open a heap dump, what objects should be suspect first? The objects that have the highest memory retained. Bravo. So we have retained memory, okay? Or maybe we have instances that we know about, maybe our own code, but that shouldn't be in there anymore at that point of the heap dump. Like, what are you doing with 10,000 loans in the middle of the night in memory? What keeps them there? And by the way, I forgot to say, every time you heap dump, in the heap dump, there are only live objects. Any garbage is being cleaned before the heap dump. So these objects remain in memory even in absence of load. It happened for ThreadLocal, for example, for us. Or they steadily increase in size over minutes, hours, even days. So remember, restart just before that. Good. Find what keeps them alive with this GC root. But GC root sometimes is not enough. Look, it's a bit darker, but the shortest path to GC root could be that you have a reference to a certain object. This is exactly from the code we had today. You could have a reference to a certain object from a worker thread of the common pool. But that's not really what keeps the fork join task array. But a better route is to see that this array is one of the queues of the common pool of this sticky icky class. You remember the song? Never mind. Sticky icky. And very well sung. Why am I rapping? Anyway, find that keeps them alive, we discussed, GC root. And then one other idea, if you really get bored one day, you could, if you have a large flow, you want to optimize the speed of a batch processing, you could start the batch, let it run, or the load test on an API. Let it run for, I don't know, 10,000 requests, just to warm up a bit things. Take a heap dump, let it run more, 10,000, take another heap dump. So basically, warm up the things, stop the load, snapshot. Fire the load again, stop the load, snapshot. Between the two, the memory should not have increased. And even this free tool has something very fun. Compare with another heap dump. Ooh. It can show you how many objects were created. And this is for desperate times, guys. It's very hard to read, but it saved this one case. I know they actually found they were allocating too many objects for no reason, and they were left in memory. Good. What is this? We discussed. So what type of leaks did we study today? We saw permanent leaks. Sublist. Sublist in a static field, kept forever, would never go away. Or also we saw leaks that basically, even the term might be abused here. It's not really a leak. It's just accidentally keeping too much memory than you thought you're keeping. The Hibernate session, if you remember. We were trying to stream over some rows. If I had enough RAM, I might never have seen the problem. And I might have to shut down REST API calls during the batch because my batch is spreading all over, squeezing all over the memory, right? So I was lucky to fail in staging and not work like shit in production. Right, then we saw limited leaks, like the one with ThreadLocals, that only grows as large as the threads in the pool. The more threads, the more waste. And they're also unbounded, like the Idempotency keys that kept growing until they crashed the system. So remember? Good. And then surprise heavy objects. You were very fast. You were indecently fast. I just put the code and said, that class is not static. Remember? Should be nested, static. Usually people start banging heads. What exactly the connection is between calculator and calculator factory? Good. And we saw leaks in our own code by playing with tools of the gods. And we saw leaks in libraries like caches, if you forget to put the max size, or shutdown hooks, very well. Good. The tools I've played with today, not all I've tried, but many. And the takeaways. The takeaways. I'm not done. I discovered 3 more leaks I need to share with you. But here, the conclusions. So out of memory in production, look, if you want to take a photo, take the photo now. Take the photo now, and I'm going to reveal bullet by bullet, right? So you get the photo, right? All good? If you're done, let the phone down. Put the weapon down. Good, thank you. Now, I'm playing with your brain. It's too much information at once, right? One by one. Out of memory error. If it happens, any further call to that machine might fail for random reason, failing to allocate whatever. So it's safer to just shut down the VM, right? And then make sure that from your production, you can get the heap dump potentially anonymized with the PayPal tool. That's a very big problem. Funny story. You know what an air-gapped system is? Air-gapped. Fancy term. Think of a bunker. Do you think they have TikTok in the bunker? TikTok, I've chosen the website carefully. Do you think they have Chinese TikTok in the bunker of Trump? Yes. Air-gapped systems is a system not connected to the internet. And I was in a workshop once with people working with such military defense things, and they said, we can't really get the heap dump from production. At one point, one of the lead ops took a stick. Let me show you. And in 10 minutes, they got the leak in front of us, the heap dump in front of us, like, oh shit, I'm not seeing this. Anyway. So the money, GDPR, credit card numbers, access tokens are in the heap. Should be cleared away. So do test that tool, PayPal tool, to prove to your ops team that it's safe to get production heap dumps. When I ask people in my workshops, do you have any heap dumps to give me, to show me? 90% of times they tell me, we once had a leak, but we never got the heap dump. It's always the same answer. The heap dump is missing. If you had the heap dump, it's child play. You saw how easy it was today. Boom, Hibernate. Boom, ThreadLocal. Basic, right? So set those flags I told you in production. Then, reduce the memory footprint of long flows or hot flows. If someone is machine gunning an endpoint and you went even virtual thread perhaps for more load, optimize the footprint. Extract DTOs, reduce. I once used, true story, I once used int array in my Java code instead of a set of long. You know why? Because it's 20 times more compact. And I had to keep 1 million items in memory to do some sort of matching of some IDs and with batch processing a file. I chose int array, and of course I put a comment. I know it's strange, don't change, take your hands off. It's for memory. Inner class and anonymous implementation or subclasses capture the outer instance. Also, Java 21 rocks. Remember? It fixed 2 problems. ThreadLocal propagates the typical. Maybe some of you didn't know about ThreadLocal. I hope I did I played my role, and now you understand that backend systems all use ThreadLocals to propagate metadata throughout our application, security tracing and transaction things. Good. ThreadLocals and thread pool are a deadly combination because the pool keeps some threads open for longer, even if the flow is finished. The larger the pool, the bigger the leak, of course. So you should finally ThreadLocal remove, or better yet, do not do that at all. Do not play with ThreadLocals yourself. Try to use some framework-managed stuff. ThreadLocal can make virtual threads heavy again. Did I show you the error? Blowing up the out of memory, and then me doing that reflection stuff you didn't like? Exactly. Thread leak due to deadlock, and we had a hard time today finding where the deadlock is. At least with the free tool I'm using, it doesn't point me directly where the deadlock is. Right? I should try this one more time. Just I'm curious about one thing. I didn't show you really how easy is to find the deadlock between. 1 second. Deadlock. Launcher. 3 seconds. Boom and refresh. And if I monitor this, the thread should now go off blinking. Do they? I'm using virtual threads still. Shit. 1 second, please. Application properties. Let's comment this. It shows you exactly when your threads are stuck. So it should be. I'm starting the wrong thing. Don't do this. Memory app. Good. So. Come on. So refresh. Come on. Refresh. Good. And now this should pop up saying, hey, we have a deadlock. Boom. Take a thread dump to get the precise location, and it tells you exactly where you are, where the deadlock is. You are now in the synchronized map get with this thread blocking the other HTTP thread. You see? It's easy, very easy to get that information. Virtual threads are still not there yet. Good. So where are we? Here. Good. Common pool. Common pool doesn't lift metadata, the thread locals into the worker thread, has an infinite queue and might compete with other parallel streams or other computable features from wherever. So that's why it's almost must-have to pass an executor as a second parameter to any async method of computable feature. Or you could just wait for structure concurrency. And long leaf collection should be bounded. Executor work queue, idempotency key, hooks, that's what we saw. Sublist, you brother. Use the cache lib, don't bake your own. Cacheable can be too magic to use. And your keys should be records, therefore immutable and hash code equals. Unit test them and monitor hit miss in production. Streaming ORM query can traverse a lot of data, but don't forget to detach. When we saw some exotic leaks like this. Oh, and I have one leftover. HTTP session. HTTP session?
Brother, what's that? What's that, brother?
How can I make it more compact to fit the screen? There. This piece of code over here shuts down your application in a bunch of minutes. It's going to create an HTTP session for every single incoming request in a REST API, and REST calls are stateless, so they're going to fire you without any cookie, any nothing. So they're just going to create endlessly new sessions. This takes your application down. Okay? Right, and I have basically, I'm almost done, just one slide, I think. Okay, good. So, basically, thank you, and I am really serious. I will offer you 10 euros in cash for any new memory leak you describe to me. Hearing about that, I already have to pay 30 euros because there are people in the room that told me. So from PIN, I hope I typed it correctly. Do you know that native memory? Do you know what defragmentation means? Defragmentation is when the older of us used to be nostalgic, and instead of looking into fire, we were looking into how your Windows defragmented. Remember? And video plus sound for the nostalgics. You can put it in case you don't have sleep. You just put it on loud. Beautiful memories. Defragmentation, making contiguous blocks available again. The problem is, the heap is defragmented, but the native memory is not. The native memory, the ones that are outside of the heap. So I'm yet to create an example that allocates and deallocates random size of objects until, because it can't fit the buffer you're trying to allocate, it's going to keep expanding the native until it blows. I want to demo this tonight. Good. And then the billion laughs attacks. Billion laughs attacks is this. We have an XML that, using doc type, if you try to parse this with a parser, it will expand to 3 gigabytes in memory. If you try to parse it with a framework without enabling some key features of protection, this can expand into 3 gigabytes in your heap. So if someone hands you over this XML, you are processing the doc type instructions, boom, beautiful. So that's 10 more euros for me. And this one, which is silly, but I will still, you have a huge tree. A tree has children and children and children, and you just concatenate that to a string, and you log it on trace for extra fun. Trying to construct the string of the entire tree results in 500 megabytes, takes your system down. How to solve this? Sorry, there are 2 ways, one good, one bad. This is the good one. The bad one is to go geek. Both of them will solve the problem. They will not evaluate the toString unless you really trace. And you don't trace. But when you want to debug this, killed production by debugging. Beautiful, beautiful. So toString shouldn't include the children and children and grandchildren, the tree structure. The toString is wrong, really. You get the point? That would be fantastic to go to production, enable this thing, boom! Fantastic. So 3 examples more from you. If you have other examples, this is really, really true. I'm going to keep until I'm collecting this. I'm a collectioner. I want to get more and more heap dumps from you. Describe the story and you get that reward. Thank you very much. And if someone is after stickers, I also have stickers. Thank you and have a great lunch, guys.